Hello to everyone at the University of Houston. Thank you for involving me in the presentation here today. Firstly, I'd like to introduce myself. My name is Michael Madden. I've been studying with the University of Houston since just January 2017 in the subsea engineering. A quick snapshot of my professional experience. I am currently employed in the petrochemical industry as a process technician, and over the past 10 years or so I have either worked in the petrochem or water treatment industry within similar roles. The topics I covered as part of the fatigue and corrosion fatigue project were examples of failures and monitoring as an analysis tool, and helped in the final compiling. The presentation touches on what was covered in the body of the project, however somewhat expands in terms of pros and cons. I would like to take a moment to acknowledge Professor Yolanda individually for all her time and supplying us with her vast practical and academic knowledge, and also for introducing / revealing a number of her known expertise colleagues within the industry. Very much appreciated. Thank you. Also thanks to Aijan for providing the TA role and responding to a number of my emails throughout the semester. Thank you. So swiftly moving on to the presentation. The significant outcome from failures. There's always a lesson to be learned from past mistakes. So post-case studies, failure analysis, so we can learn what happened. Design of new, safer and more reliable materials. So I think it instills a continuous improvement. We're not just going to go back, putting back in what failed. So continuously improve it. Recognition of test all possible scenario philosophies. So I think that again comes from failures. Leave no stone unturned, and validation procedures. So a list of steps that validate it, that it doesn't fail. Introduces new technologies and engineering concepts. So invention, more efficiency, reduction in waste. So reinvention. We're not going to put back in the same thing. Reinforces traceability and documentation as warranty, accountability, quality assurance. So again, we want to make sure there's accountability there if something fails. Consequences as a result of failure. Loss of life, individual loss of life. So it also affects the wider family, friends and loved ones. So, it's a bigger spectrum. Health, it's undefined. A lot of these major oil and gas failures, we don't know the possible side effects to our health as of yet. Cost to employees, individual employees, the company can go into liquidation, and economy. So let's say Norway, for example, that has a huge investment, it can harm the economy if there's a big failure. Environmental damage, wildlife, contamination of waterways, alteration of ecosystems. It can move out species out of ecosystems. So on to monitoring. Monitoring is taking an input from the real world, process, output and evaluate. So look back through it. And more so added control and circling back and monitoring again. So on the right hand side we have an overview of sensors, signal conditioning, microcontroller, Arduino, GPS and web. So the majority of real world quantities can be sensed or sampled, which generates into some form of compatible energy. So let's say a thermocouple, we get voltage, or other sensors we get current, or we can use light. The signal generated is defined as an analog representation of the measure quantity, which with respect to time continues throughout its length. As part of the signal conditioning, the signal is sampled at regular intervals, so spot sampled, and converted from analog to digital representation, intermittent with respect to time. The signal is now compatible with microprocessor equipment and can be further transposed into other comparable spectrums or dimensions. So frequency domain, fast Fourier transforms, or Laplace, for example. It also has the option of this information being networked over a range of platforms for reference between different disciplines, operation and engineering, for example. The data can be viewed through a range of applications such as Microsoft Office software, or remain as historical data for auditing purposes, for example. So monitoring support features. So in a bigger spectrum, or a bigger scope, you can do it micro to a micro level or a macro level, so standalone to World Wide Web networking. Traceability. Historical archiving of data provides future reference for and audibility. So again, we've seen that in failures. Controllability. Online monitoring supports real-world alteration or rectification. Continuous improvement. Tuning a process for optimization, removing inefficiencies by minimizing the range on the process variable tolerance. So let's say we have a process tolerance of plus or 10%. We can bring that down to plus or minus 5 if possible. So that was a brief run through, and thank you for your time and listening. If you have any further questions, I'd like to hear from you. My email is displayed there on the bottom of the screen. Thank you. Bye.